Okay, so I'm going to record this video to talk about two special types of discrete probability distributions. The first one is something called the binomial distribution. And the binomial distribution is a result of a random experiment that happens over and over again. So we have n number of trials, and on any given trial we have p probabilities of success. And each trial is independent. So what's the odds that we flip a coin 10 times and we get 3 tails? Well, that would be a binomial experiment. What's the odds that if we play 10 games that we lose 3 out of 4? Those are results of a binomial experiment. There is a formula for that, which is on your screen, but that formula is not what we're going to use for the homework. I'd rather you use Excel. So I'm recording after we go through this, there's a table as well. We're not going to use that. After we go through the second distribution that we're going to talk about in this section, it's called the Poisson distribution. And that distribution is also discrete, but it's used for number of successes over a region or space. So that is a function of Excel that we're going to use as well. You'll see the homework is using this formula, which is kind of a cumbersome formula, but there is a function in Excel that can do this for us. So what I'd like to do is I'm gonna kind of skip out of this. I think you guys can get those things through your home or through the material. But I'm gonna go to Connect, and hopefully you can see this. So let's do Chapter 5, Section 3 and 4 homework. Okay, so this you'll see is going to utilize binom dist and the Poisson function. Okay, so let's look at this first one. It says 30% of all customers who enter a store will make a purchase. Suppose that 6 customers enter the store. So there's a 30% chance that's going to be our P, our probability of success on any given trial. 6 customers is our N, and it's independent, so it's binomial. It says use the binomial formula to calculate the probability exactly 5 customers make a purchase. So let's go to Excel, and let's go through the binomial formula. So there is, and let me open this and make it big. There is a function in Excel that we want to use, and it's called binom dist. So I'm going to type in equal binom dist, and it needs 4 flags. First, it needs the probability of success, and I think the first one said, what's the odds that I have 5 in 6 trials? So X is 5, N is 6, and the probability of success on any given trial is 30% in this case. And this last flag is true or false. And false means equal to, or point probability. True means cumulative. So I'm just looking for the probability that X is equal to 5. So I'm going to put false. If I was looking for 5 and less, I would put true. And it gives me 10.21%. If we look over here, rounded to 4 decimal places, or sorry, it's 1.2%, 1.02%. That's what we got over here. Let's look at the next one. At least 3 customers make a purchase. So this one's a little bit, let's do number 3 first. It says use the binomial formula to calculate the probability that 2 or fewer customers make a purchase. 2 or fewer. So we're still talking about 6 trials. Sorry, someone knocked on my door, so I was interrupted, but I think this one we're looking for the odds of 2 or fewer out of 6 trials. So we're going to use 2. Number of trials is still 6. Probability of success is still 30%. But because we're looking for 2 or fewer, we're going to use the flag true, because that means cumulative. So I put in true, and it tells me 74.43%. And that's what we have. Now, let's go back to number 2. It says use the binomial formula to calculate the probability at least 3. So we're looking for 3 or more. Well, we don't have a flag to do or more, But we do know that probability of all the occurrences, all 6 or all 7 outcomes is equal to 1. So if we do 1 minus binom dist and subtract out 2 or fewer, we're going to be left with 3 or up. So follow that logic. We know that there are 7 possible outcomes. We can have 0 success, 1, 2, 3, 4, 5, or 6. We want 3 or more. I think it's 3 or more. So we're going to subtract out 2 or fewer. That's what we're doing here. And we get 25.57%. So hopefully that makes sense. Now, the same is going to be true. Let me find a Poisson distribution. This one would also be binomial. And this one would be binomial. And this one would be Poisson, because a retail store has implemented procedures aimed at reducing the number of bad checks cashed by its cashiers. The store's goal is to cash no more than 8 bad checks per week. The average number of bad checks cashed is 11 per week. Let X denote the number of bad checks cashed per week. Assuming that X has a Poisson distribution, find the probability stores will not cash any bad checks in a particular week. So this first one is, if the average is 11, what's the odds that we get 0 cash checks, bad checks? So we're going to use, instead of binom dist, we're going to use equal Poisson. X, the number of successes. When the mean is 11, I'm going to say false. And what that really is giving us, that scientific notation for let's do general. And that is 1.6701, which is move the decimal place 5 places to the right. And let's do number, and let's think for decimal places. So 4 decimal places would be 0.00000, 4 zeros. Let's look at the next one. Find the probability the store will meet its goal during a particular week. So our goal is the average number of the store's goal is to cash no more than 8 bad checks. So no more than 8 bad checks. So we're looking for the probability of X being less than or equal to 8. So we're going to say equal Poisson, 8, 11, true, because 8 or less, that's definitely cumulative. That gives us 23.20%, and that's our answer. So all this logic is the same for binomial and for Poisson. We need to use the formula, and we need to figure out what it's looking for. If it's looking for equal to something, we're going to use the formula and then use false. If it's less than or equal to, we'll use the formula and true. If it's greater than, it's going to be 1 minus. Okay, 1 minus, and it'll be true. So hopefully this was helpful. Hopefully go through the homework. And please use the Excel function. There's going to be an assignment on that later, because I think, rather than do the math, I think the Excel function is just much better. Thank you.